Hi everyone, welcome to the sixth session of Unit 1 on blockchain and smart contract. This session we are going to talk about permissioned blockchain, what they are, how they work, and why they are different from public blockchain. What is a permission blockchain? A permission blockchain is a restricted blockchain network. The meaning behind that is not everyone can join inside the network. Unlike a public blockchain like Bitcoin or Ethereum, where everyone can participate, in a permission blockchain allows access only to approved participants. Think of it like a private club. You need a permission to enter and your actions inside the networks are controlled. So in a permission blockchain, the participants must get authorization to join the network. They have some specific rules. Some may only read data while others can write or validate the transactions. So this is the way how that permission blockchain works. For example, imagine a banking blockchain where only the approved banks and financial institutions can participate. As a bank employee may have a permission to read transaction record. A bank manager may have a permission to approve transaction. A central authority like a regulator may have a permission to audit the record. This level of control and security is what make permission blockchain ideal for business, governments and financial system. Why we use a permission blockchain? So it will comes with more control, better security, faster transaction, regulatory compliances. So a permission blockchain is the best organization that need a privacy, security and control over their network. Unlike a public blockchain that allow anyone to participate, the permission blockchain is restrict access to select group and ensuring faster, safer and more efficient transaction. Now we are going to see about the key features of this permission blockchain. The first feature is restricted access. Not just anyone can join. The participant must be approved by the governing body of the blockchain. Only the authorized participant can join the network. The access is controlled through authentication methods like a digital certificate and identity verification. For example, a banking blockchain allows only approved financial institutions to join. This ensures compliance with government regulations. The second feature, it comes with an identity verification. Unlike a public blockchain where users are often anonymous, permissioned blockchain require identity verification before granting access. This done using public key infrastructure, digital signature and cryptographic certificate. So in Hyperledger Fabric, every participant must be registered with the certificate authority before they can join and perform transaction. Third feature, governance and control. A centralized or semi decentralized authority governs this blockchain. This can be a single organization as a private company or a consortium of organizations, the banks sharing a financial ledger. For example, R3 Corda, a blockchain used by banks, is governed by financial institutions to comply with banking laws. The fourth feature, customizable permission. So the permission blockchain allow the role-based access control. Not all participants have the same rights. The permission blockchain allow role-based access control. It may provide read-only access, they can only view the data. Validator nodes approve or reject transactions, and full node permissions can propose and validate this transaction. So example, in a supply chain blockchain, the manufacturers may add product data, but retailer may only read the product history. Now, the last feature, more efficient consensus mechanisms. Not all nodes participate. Here, since the permission blockchains have a limited number of trusted participants, they do not need energy intensive mechanisms like proof of work. Instead, they use faster and more efficient consensus like proof of authority. Here, the transactions are validated by trusted nodes with verified identities and practical Byzantine fault tolerance. That means the pre-approved validators reach consensus through messaging and wrapped consensus. A leader node coordinate transaction among trusted nodes. So for example, a Hyperledger uses PBFT like a mechanism, making it much faster, more scalable than Bitcoin's proof of work. So in the case of an key features of permissioned blockchain, it will comes with better security. Only verified participant can access the network and more control. The organization can define who can read, write, and validate the transaction, and it provides the faster transaction. No need for energy, heavy consensus like proof of work, and regulatory compliances. It's ideal for banks, healthcare, and supply chain network. So the permissioned blockchain provide a secure, efficient, and controlled way to manage blockchain networks that making them perfect for business and enterprise use. How the permission blockchains works. A step-by-step procedure we will see. The first process is onboarding participants. Not just anyone can join a permissioned blockchain. Organization must apply for access and go through identity verification before being allowed to the network. Imagine a healthcare blockchain that stores patients' record. Only licensed hospitals and doctors are granted access, ensuring that private medical data stays and secure. The second step, consensus and validation. Unlike a public blockchain where thousands of anonymous nodes compete to validate transactions, but in permissioned blockchain rely on a select group of trusted validators. Because of this, this make a transactions faster and reduces computational overhead. For example, in a trade finance blockchain, only approved banks validate international trade transactions, that ensuring efficiency and security in a permissioned blockchains. The third process is data privacy and access control. In permission blockchains, allow fine-grained access control. So what is the meaning of this fine-grained access control means? Some data can be public, some data remains private. The timestamps of transactions are the public data and the contract details visible only to the involved parties are the private data. For example, the IBM Food Trust blockchain allows supermarkets to track the origin of the food to ensure safety, but the farmers can hide their internal pricing details to protect business strategies. The fourth one is a governance structure. Since the permission blockchains are not fully decentralized, they require a governing organization or consortium that defines the network rules and the dispute resolution policies and upgrade and maintenance policies. So, for example, Quorum, a blockchain developed by JB Morgan Chase, is governed by participating banks that ensuring compliance with financial regulations. So the use cases of this kind of permission blockchains in industry-wise banking and finance, the use case secure and transparent transactions. Example JP Morgan Quorum. In supply chain industry, the use cases of permission blockchain used in product tracking and authenticity verification. Example, this process is done by IBM Food Trust. In the healthcare industry, the use cases of this permission blockchain securing patient data and sharing. The Medreg blockchain that will provide the data only to the licensed hospitals and doctors. In government, the use cases digital identity verification and voting system. In enterprise data, secure collaboration across the business. So these are all the some use cases of this permission blockchain in various types of industry. So the permission blockchains highly ensures the security and privacy, meaning only the trusted participants can access the data. The efficiency is somewhat higher. The faster transaction with selected validators. Not all the validators will do this validation process, only the trusted validators do their validation. So its efficiency is very high compared to the public blockchain. Control. Governance ensures the compliance with regulations. It will comes with the good governance and scalability. So it is a customizable for industry specific needs. So the scalability issues will be totally reduced compared with public blockchain. So the permissioned blockchains are perfect for business, bank and governments that need security, efficiency and control in a blockchain network. The key advantages of permission blockchains and why they are widely used in industries like finance, healthcare and government applications. The first one is enhanced privacy. The data transactions are visible to only the authorized participants. The data access is restricted here. How do the permissioned blockchain ensures this privacy? So this is to be done by role-based access control. So what is meant by role-based access control is some participants can only read data while the others can validate transaction. Private transactions. Some frameworks like a Hyperledger Fabric allow certain data to be hidden from unauthorized users. Confident small contracts. Only approved participants can view contract details. For example, IBM Food Trust blockchain allows supermarkets to track food origins while keeping supplier price details private. The second one is called improved efficiency. Faster consensus mechanism reduces the transaction time and computational cost. Why the permission blockchains faster? Unlike a public blockchain, the permission blockchains do not require proof of work, meaning no complex cryptographic computations are used in this permissioned blockchain model. They use efficient consensus mechanisms like practical Byzantine fault tolerance, proof of authority, which finalize transaction in seconds, not minutes. Only verified participants are allowed. There is a less congestion compared to public blockchain. For example, in a Hyperledger Fabric can process thousands of transactions per second, whereas Bitcoin handles just 7 seconds per 7 transactions per second. Third one is regulatory compliances. Identity verification and restricted access enable compliance with legal and regulatory frameworks. Why do industries prefer the permission blockchains means it will comes with an identity verification that ensures compliance with know your customer KYC regulations in finance. Permissioned access allow companies to meet data protection laws like GDPR, General Data Protection Regulation, and HIPAA, Health Insurance Portability and Accountability Act. And audit trails provide transparency so the regulatory bodies can review transactions when needed. For example, in a JB Morgan's quorum is designated to comply with anti-money laundering laws. In addition to that, the advantages of permission blockchain, it will comes with lower energy consumptions because no proof of work is to be required. Finally, why these kind of permission blockchains are important compared with public blockchain means they are faster, they are more secure, they provide better privacy, they meet regulatory standards, and they are energy efficient. As the blockchain technology evolves, the permission blockchains will play a critical role in industries that need security, efficiency, and legal compliances. While the permission blockchains offer a great benefits like efficiency, security, and compliance, they also come with some challenges that businesses and organizations need to be aware of. The first challenge is centralization risk, controlled by a single entity or small group. What is this issue? Unlike a public blockchain, which are fully decentralized, the permission blockchains are controlled by a central authority or a small consortium of organization. Why this is a problem? A single entity or a fewer participant control decision making. There may be some conflict of interest may arise if governance is dominated by a select group, and there is a risk of corruption or manipulation if governing body is unfair and there is a no decentralized system to stop them. For example, a private bank running a permissioned blockchain might prioritize its own interests over fairness to customers. In corporate blockchain network, a few dominant members may override decisions, sidelining smaller participants. The second challenge what we are facing in permissioned blockchain is limited trustless interaction or limited decentralization, trusting a few validators. Why this as an issues means the permissioned blockchain rely on trusted validators to maintain the network. This means less decentralization compared to public blockchain. Why this is risky means trusted dependency. So the participants must trust the administrators and validators, and single point of failure may be possible. If key validators go offline or compromised, the entire blockchain could be affected and easier to attack. If a public blockchains, an attacker need 51% of control to alter transaction, but in a permission blockchain, fewer validators make it easier for hackers to infiltrate and manipulate the system. For example, in a banking consortium blockchain, if a few large bank control consensus, smaller institutions have little influence over a decision making. And potential for censorship. Governing body can restrict access. Why these issues will come? The permission blockchains require approval to join. The governing body has a power to control who can participate and which transactions are allowed. The censorship risks include blocking users or organizations from participation, modifying transaction rules without consent from all the participants, and enforcing restrictions that benefit some members over others. For example, a government controlled blockchain could restrict financial transactions based on political reasons, and it will comes with less transparency. Only approved participants can verify transaction. The public blockchain allow anyone to verify transaction. In contrast, the permission blockchains limit access, meaning only The selected participants can audit the ledger. So there may be some transparency challenges here, lack of independent verification and limited public accountability and trust in the government authority. So there may be some security risk is also possible in the case of challenge, challenges of permissioned blockchain. So while the permission blockchains offer efficiency, security, and regulatory compliance, they also come with challenges like general centralization risks, limited decentralization, censorship potential, less transparency.